Find an equation for the function f with the given derivative passing through the given point. Okay, so f will be the antiderivative. I'll bring out the 2, and we don't have to do that, but I usually like to factor that out. In this case, it might be beneficial to leave it there because you can see it's the derivative of the input function. Okay, so some of you might be able to just go ahead and give me the antiderivative here plus c, solve for c, because you have that relationship u and u prime. But I like to do all these u substitution because it's not always that clear. So when we do u substitution, I always let u be the input function of the composite. So there's a square root, and then this is the input. And then du, negative 2x dx. Solve for dx, and you'll get du over negative 2x. Now do your substitution. Negative 2x. I got a sub for that. I got a sub for that. And if we would have just left the 2x alone, we would have been okay. Those cancel out. And the point of doing u substitution is to get a integral that we can handle without too much trouble, and that's what this is. So I use my general power rule. And there is my antiderivative. I back substitute. And now all I got to do is solve for c. Okay, so to solve for c, I use this point. Another way to give you that point is to say f of 2 equals 7. So this is f of x. So f of 2 is 2/3 x minus 2, input 2, to the 3/2 plus c. And we know that's equal to, based on the information, that that's got to be equal to 7. Okay, so solve this for c, and I'll be done. So I got, what do I got? 2/3, 8 minus 4, 4 to the 3/2, plus c equals 7. So what's the best we can do with this? Well, I don't know. We could find 4 to the 3/2, right? Because 4 to the 1/2, or the 2 represents the root. So that's the square root of 4 and then cubed. Square root of 4 is 2. Cubed, you get 8. So I got 2/3 times 8 plus c equals 7. And that's going to be 16/3. So I'll just subtract 16/3 from both sides. And c is 7 minus 16/3, or if you put that over 3, that'd be 21. So I got 5/3. Okay, so that goes here, and then that's my answer. 2/3, 8 minus x squared to 3/2 plus 5/3. All right, so this one is an indefinite integral. This one was like a differential equation. There doesn't seem to be a lot of trouble with the definite integrals. Most of those looked okay. So here's an indefinite integral. The trick with this one is you still would let u be 5 minus x. And then when you substitute, you'll have a problem, right? If you do this like we've done the previous ones, du dx would be negative du, so we can put a negative out there. So here's the problem. You don't have you still got an x involved, right? You don't have an integral just in u. So what we have to do is sub out this x somehow. It doesn't work its way out like the last one, but we have that relationship. If u is 5 minus x, and you could solve this for x, right? X equals, I could add x this side, subtract u, 5 minus u. So then if x is 5 minus u, then what I end up with is 7 minus u times u to the 1/2 du. That's all negative. Integrate, I'll run this guy through, and that gives me negative 7u to the 1/2 minus u to the 3/2 du. And then I can integrate that guy, and I get negative 7u to the 3/2 times 2/3 minus u to the 5/2 times 2/5 plus c That should give me what? 14 over 3. So let me simplify that guy. Negative 14 over 3. And then I could run this negative through. That could be helpful. That would give me 14 thirds u to the 3 halves. I'll leave a space for u, or we can just fill it in. It's 5 minus x minus 2 fifths. 5 minus x to the 5 halves plus c, final answer. Okay, now you could simplify the computer should accept that as an answer. That's how I'll take it. That's fine. What a math textbook or computer input, a computer program wanted to do is you could simplify this by what could you do? You could factor out a 5 minus x to the 3 halves, and then maybe you'll get a nice simple product. But this is fine. There's no need to really go any further. Okay, so I hope that helps. If you have any questions about any of the other problems, please let me know. I can do more of them.